Ladies and gentlemen.
This meeting is being recorded.
Yeah, so don't do anything you wouldn't do in public. Let's see, what do we got here? April. And today's presentation is going to be on the Linorobot from Juan Miguel Jimeno. He's in Singapore. The Linorobot comes from the Tagalog Talinas, which means intelligent. And it's going to be a really great presentation. It's a neat package. Before we go there, let's see. Anybody got any robot news? Come on. I saw where Melanie Wise got the, help me out, Dr. Ed. What's the award?
Engelberg.
Got the Engelberg Award for Technology, one of 5. Pretty prestigious industrial technology award. Engelberg, the father of robotics. There we go. Thank you very much. How can I remember that? Okay, so any more robot news out there? All right, moving forward, let's get into club news now. Wayne, I think you have some information about potential real in-person real life. Go ahead.
So yes, a number of us have been talking about getting the back together in a real meeting format. And the requirement is, since we have picked up a lot of people on the internet, we need to come up with a strategy which allows us to have both in-person and network, people coming in over the network. Prior to this, we had a pretty awesome facility donated to us by Google that was a huge room, and B, came complete with an audio-visual tech. It's just, Google sells a lot of advertising. That's all I can say. Anyhow, we now think we're going to get that building back, that facility back. And so we talked about it, and we've come up with a strategy that we're starting to execute on. Most of you have heard of the concept of a maker space. The San Jose area has gone through 2 or 3 generations so far of maker spaces, from the original tech shop work maker space, which it had its ups and downs. The current one in the Bay, the South Bay area, is called Maker Nexus, and it's in Sunnyvale. And what we're trying to do is set things up so that we can meet in person at this facility. That the 2 people who are leading this charge are myself and Al Margolis. We'll probably be asking other people to pitch in as we have things that need to be done. Because we are a builders club, it makes a lot of sense for us to be hooked up with a maker space, because it may be a good fit for some people to join Maker Nexus to get access to all of the goodies they have there. It is a significantly larger facility than the first one they had. I think it's at least 7,000 square feet, and it's actually quite nice. Now, we're not going to go from 0 to full capacity in our first shot. So the initial attempts at it will probably have limited attendance, not because we don't think we can ramp this thing up. It's just that you want to make your mistakes with a smaller group of people that are going to be understanding of technological glitches. So that's kind of the rollout that we're going to do. Is we'll probably have some sort of Eventbrite, or whatever the name of that outfit is, give away free tickets, and then when you're out of tickets, well, that'll be as many people as we can do.
Everbright?
And the goal is, Eventbrite.
Eventbrite, yeah.
So anyhow, that's what's going on. We're going to have to work out the audio visual aspects and seating aspects. And it's going to take a while to ramp it up. But, the hope is that by the end of the summer, we will have something up and running, and we'll be able, for all the people who are local in the area can show up. And then we'll, of course, still be able to do the entire presentations online and share online as well. That's the goal. So that's the quick overview. I'm going to let Al chime in if he wants to say something, and then we can open it up to a few quick questions, and then we'll move on to other club news and other stuff.
Yeah, I went through the facility in detail today, and there's actually a nice existing audio system that was abandoned by the prior tenant that I suspect works. And so that's going to be my first job, is to get that activated. But, my goal is to get started with small meetings soon and then ramp up, as quickly as we can handle the activity. And, I don't know what everybody's personal feelings are about meeting in person. I'm ready to start tonight if it had been possible. But, I know lots of other people who just will not go to large group events anymore. So we just have to see how the whole thing grows.
Sounds good. Okay. Does anybody have any quick questions? We don't want to take up the entire meeting on this, but if anybody has a few quick questions, we can probably answer those as best we can. If not, we'll move on. Going once, going twice. Back to you, Camp.
Moving right
Camp.
along.
This is Dan. I have a related announcement.
Okay.
Oh, go ahead, Dan.
Okay, the related announcement is we're always looking for people to join the club. You don't have to join the club in order to participate in these wonderful Zoom meetings. But you'll need to have a badge. I guess you don't technically need a badge to go to the live meetings, but it's a lot better if you have one. Look at that. Can't hold that up again. That is so cool, so valuable to have.
You two can have a valuable HBRC badge, have all the prestige and honor that comes with being a Homebrew Robotics Club member in good standing.
So seriously, the membership is what drives the club. It's the lifeblood of the club. If you haven't joined, it would be great if you did. Again, you can attend these meetings and get a lot of value out of the club without joining, but we encourage people to join. $10 per year per family, best deal in Silicon Valley. More details are up on the website. So yeah, hopefully more people will join up, and then when we meet live, you can all show each other that cool badge that's got a convolutional neural network on it. If you didn't catch that on the video. Okay, hey, back to you, Cam.
If I send $2 extra, can you send it? Can you mail it to me?
We offered that for $5 extra, we'll mail them out. So I don't want to change the offer now. For $5, provide your mailing address and we will get that to you in the mail. That's how Camp got his. Okay, thanks.
And when we do get together physically and have the extracurricular events, that is, go out as the Homebrew Robotics Club, it's required that you be a member in good standing to go on the extracurricular event. So there's that. Okay, moving along. Club news. Martin Triplett, are you out there? Don't mean to put you on the spot. Don't mean to put you on the spot. Yes, I do. Are you giving
Can
the
you hear me?
presentation? Are you giving the presentation next month?
I am.
Okay.
Yeah, it's going to be this robot here.
Awesome.
I don't know if it's going to be software or hardware. So if anybody has any preferences, send me an email.
Can you give us a quick overview?
I started building robots about 10 years ago, and this one, I've been working on the software for it for 3 or 4 years. The hardware was built probably about a year ago, And it's still a work in progress. This is going to be my main project for the next 10 years probably. So I wanted to build a robot that had a little bit of everything in it.
It's
So I
awesome.
wouldn't
Well,
run into limitations.
there's something to look forward to next month. Okay, super fine.
I can talk about it for as long as anybody wants to listen, so.
Very fine. Next month, Martin Triplett, and your robot's name, Martin?
Ava.
A-V-A?
AVA, yeah.
Ava, very nice. All right, looking forward to Ava by Martin Triplett. Okay, cool. And then the month after that, you are responsible for the presentation. That is, will be phase 2 of our 20th anniversary HPRC challenge. So get your robot running. All right, any more club news? What about what I need help with? Anybody need help with something? Have a quick question you want to put to the group?
Are we done with general robot news?
First, yeah, Dr. Bott, what do you got? What robot news do you have?
Well, I got two things. First thing is the first Robotics National Championship was last weekend. And the perennial San Jose favorite team, 254, Cheesy Poofs, won their 5th championship.
The Cheesy Poofs. All right.
Cheesy Poofs won.
Great group
However,
of kids.
7 teams from California made it to the top level, including Redwood City, Team Bread, 5940. Citrus Circuits out of UC Davis were there. Madtown, 1323 Madera. Let's see, some other teams that didn't quite make it all the way to the top did very well. Mountain View High School, 971. The Funky Monkeys, Quicksilver. I don't know, it was like a sort of like a California party there. 7 out of 24 teams in the top level made it to what they call Einstein. That's the final level where they have the top 6 alliances, and 5 of the 6 alliances had a California team on it.
That's awesome.
Some of them had 2. Okay, the second item is I have finally got a Noetic robot working on the ARM64 version, Raspberry Pi revision 1.4. I don't know if the 1.5 blows everything out of the water.
Are you talking about Magni now?
Yeah, Magni. I have a Magni with the laser, with the camera, MMAL, everything working on ARM64.
You got a
not the
demo for show and
ARM32.
tell?
What?
You got a demo for show and tell?
Not right. Well, not right now, but
All right, just testing you.
next meeting.
Sounds
next
good.
meeting.
Okay, what else? Any more robot news or club news?
Hey,
What I need help?
Yeah, I need help with a Magni. I have an older Magni that David gave me, and the motor board, I guess, has an older driver on it, and so the current distro doesn't really want to run it, and I need someone that kind of knows the Magni to help me with that.
Yeah, why don't you contact Mark Johnson? He's a club member directly. You probably have his email. Not
Yeah,
I'll
yeah,
send
I
it
know
to you.
Mark.
Yeah, Mark is the motorboard guru.
Okay.
What I need help with? Anybody? Don't get me started. All right, let's keep this show rolling and show and tell. Who's got a show and tell? George, I see your hand up. Oops, George, you're muted. You're muted, dude. George.
There we go.
Oops. I'm sorry. Try it again. You're muted. You're muted.
Is that better?
There we go.
Okay, did it come through?
Yes,
We can hear you now.
Okay, yeah, I have a short video if I can figure out how to show it.
go for it.
Oh, okay, now let's see what I need to do to get a video.
You're gonna, hang on a sec. If you're not quite ready, I can give you,
No,
I can give
I'm ready
you,
to go. I'm ready to go. It's a matter of what do I do to show a video?
share screen. Do you see share screen below?
Yeah,
Okay, click on that. And the
okay,
menu will pop up and just share your whole screen and show the video like you were watching it.
okay, let's see. Let's see if I can do it this way and get it. I did this afternoon. Okay, so let's see. Yeah, let me get it started because it's funny the way this works. Let's see.
You want to click the share audio button if it has audio.
Okay, here we go. Let's see. No, there's no audio.
Yeah, narrate it.
Yeah, there it is. Okay. Yeah, remember last week or last month, I said I was building a self-balancing robot. Well, there it is.
That's what chip are you using there? What computer?
It's a Pro Mini Arduino.
Okay, okay.
And then these are two power boards that do the thing, reduce the power using a 7 whatever volt battery that's
What?
and by the way, this paint paddle is the pendulum. It worked out.
Roby-Doby?
Yeah, this is Gobi Dobi.
Roby-Doby?
Yeah, it turns
Easy
out.
for you to say. Play
Yeah.
it one more time.
Oh, well, it's kind of funny. Notice there's, oh, let's see, maybe I can do it just making this. Oh yeah, good. There we go. Now, notice there's a lot of jitter in it. Okay, so my next plan, I'm working right now to try to understand Kalman filter. And I've done it before, but I want to try to get a Kalman filter working on this thing to try to smooth it out some. So,
Roby-Goby. We're
yeah.
hard to impress, but easily amused.
Yeah, right. Anyway, the lights there are hooked to the power for the motors, so you can kind of tell what the motors are up to.
That's
And,
sweet, George.
okay, already it uses a, you know, this standard, what is it, 6050 MPU board here. And anyway, the tuning of the thing was the trickiest part. Getting the parameters set, it took me quite a while to do that. I've seen some of those kind of similar ones that they actually use pots. So you could reach down and turn the pots to do the tuning. Anyway, that's it.
Super
George,
fun.
are you balancing by turning the wheels or are you balancing by the pendulum or both?
Well, the pendulum has to be there. By the way, if you take the pendulum, if you take the paint pedal off with those parameters, it won't balance. So the paint pedal is there to provide the pendulum that the PID is trying to stand on in, or part of the pendulum at least. The whole thing, of course, probably operates as a pendulum. It's really fun stuff to play with, let me tell you.
Very nice.
Very cool.
Looking forward to see Roby-Goby at the challenge next month.
Yeah, with a Kalman filter, hopefully.
Sounds good. All right, who else got a show and tell? Speak up.
Yo, I do.
Okay, who's that? Ralph Hips?
Ralph Hips, yeah.
All right, the hipster. You got it, Ralph.
Okay, so I'm going to share a video, and I can just use share screen for that.
Sure.
Okay. Let me see here. Hang on. Share screen.
Okay. Blackbeard test run, triangular.
Here we go.
courses
Can you see
and
that?
around the window, around the tree and back, in theory.
You guys see it?
Let's see what happens.
Yes.
Okay. I have two 1-minute videos. This is the first one. This is using the solar compass for navigation and attempting to drive a triangular course, sort of like a slice of pizza pie in shape. And this is the first waypoint. He's turning left to go to the next waypoint, etc.
The video is very choppy, Ralph, so you know.
Probably internet issues.
What's this robot's name?
His name is Blackbeard.
Oh,
I
yeah.
don't know if you saw that, he just sort of bounced off the tree there.
Yeah.
Kind of fun.
What's that? Is that an 1/8 inch RC car? Or 1/8 scale?
Yeah, 1/8 scale, yeah. Yeah.
But
so that's the first video. He actually managed to get back to roughly where he started, which was the goal. And so that's the first one. The second one is
Is all your GPS on board?
no GPS,
Okay, Blackbeard.
solar
touchdown,
compass,
triangle,
solar
forward,
compass
south,
and
window,
odometry. That's it.
Around the tree. and-
Wow.
Yeah,
There you go.
no GPS, no compass, no magnetic compass, no GPS, just a solar compass.
What's it? Oh, solar compass is based on where is it looking towards the sky to see this?
Yeah, there's basically like a little it's like a sundial basically on the robot on the end of the mast. So you kind of see it as they get close. There's like a little stick there and some photo sensors just above the flag. And yeah, that's how he does that. And this is
Second waypoint.
he reached the second waypoint. Here's where my obstacle avoidance finally works. He actually bumps into the fence and he decides to back up, which is
How are you specifying those waypoints?
I have a list in the code of the waypoints, and I basically tell it, drive this course for this many ticks on the encoder
Okay,
to
got
reach
it.
the next waypoint.
So it's
So I
dead
just have a
reckoning.
list of those.
Got it.
Yeah, pretty straightforward.
All
Yeah.
right.
So
Ralph Pitts, ladies and
there
gentlemen.
you go. That's it. Yeah.
That's awesome, Ralph.
Thanks.
Who
man.
else? Who else has a show and
Sorry,
tell?
I'm still not sure about that.
Yeah. Who else has a show and tell? I do. Let me share my screen. Ralph?
You talking to me? Do I need to undo? Oh,
Skip
stop
above
sharing.
here.
Sorry,
An
right.
option to exit.
There it is. Yep.
Thank you.
Sorry, I forgot about that.
That's okay. That's awesome. Solar compass. I'm gonna have to do some research on that.
Solar
So here I've got my bot vac, my ultrasonics. I've got a camera on there, and I have teleop keyboard. This is not just a virtual robot, it's a physical robot. This is the Nito package. A lot of people have been involved with this. Let's see here. Where's the- hang on. Yeah. Can you see the robot? No, you can't see the robot because it's sharing the screen. Chris, can you highlight my phone? Can you spotlight my phone?
I will try.
You know, I mean, regardless, I just want to do the show. I'll just do the show and tell. Okay, so here's this. And here's the camera. I've got ultrasonics on here, and I can control it with the keyboard, which is no big deal. What I want to do here is do a floor bot challenge. I'll go back and forth in the kitchen. Okay, so let's go here. Can you see my screen? Here. Here, yes. And here.
Yep.
Okay. And so I'm going to start navigation. And so here the robot will go from one room to the other and back.
mute on. Sorry about that. My phone seems to have gone kaput, so I'm back on the computer. Anyways, does anybody else have a show and tell? Well, without any further ado, let me introduce our guest speaker this evening, Juan Miguel Jimeno, who is the owner of the Linorobot project. Juan, we're on, and you're muted. Do you want me to run the PowerPoint? Just a note to
Can't you sound
everybody,
like
listening, please mute your
We can't
microphone.
understand
Anybody
you.
hear
Sound
you?
like you're underwater.
That's what
Can you hear
you
me
said.
now?
Oh, God. Sorry, I don't hear anybody. Can you hear me?
Yep.
Okay, I'm sorry. You're on, and I was just saying that you're the owner of the Linorobot project, and you're in Singapore right now. And did you want me to run the PowerPoint slides, or did you want to run them?
Yep. I prepared some slides and videos.
Yeah, would you like me to run them, or are you going to run them? The slides?
Sorry, you're a bit muffled. You mean I can proceed now? Yeah.
Yes.
Okay. Cool. Okay. Share my screen here. Right. Are you seeing this?
Yes, we are.
All right. Okay. Hi everyone. I'm Juan. I'm from Singapore. I'm currently working as a researcher in one of the IT firms in Singapore doing robotics. So today I'll be talking about one of my projects, one of my very first ROS projects when I was started to learn ROS around 7 years ago. So it's called a Linorobot. I think Camp has done a good introduction about the project itself. So, but a brief introduction is that it's supposed to help users, researchers, or students to have a sort of a template on building hardware and software projects that's compatible with ROS, right? So here you see the project page. It's called Linorobot. So the idea is the project supports different kinds of robot bases. So you do have two-wheel drive, you do have a car steering type of robots, you do have four-wheel drive and mechanical robots, right? So the project itself has some basic design and implementation of the hardware that you can use to control the robots and control with ROS. So it comes with the templates as well. It comes with different variants of sensors, right? And a few low-cost hardware and sensors and lidars that's available in the market, right? So that's Linorobot 1, which is the very first version. So today I'll be talking about Linorobot 2, which is, if you already heard about ROS 2, it's the next version, so-called the bleeding edge version of ROS 1. And so I created a new version it's compatible to that. So just a brief introduction about myself. So currently I'm maintaining this repository called CHAMP. So it is a quadrupedal development framework for if you want to build quadrupedal robots, right? So as you see here, it supports different various types of quadrupedal that you will roughly see in the market right now. So you do have an animal here, which is from ETH Zurich. We have a MIT Cheetah. So the idea is that in the ROS ecosystem, when I was building this 3 years ago, there wasn't much of a simulation pipeline and an engine that allows robots and open source quadrupedal robots to be run, right? So this project tries to fill in that gap. And yeah, just a few samples of that robots. So here's the MIT Cheetah navigating using the locomotion stack of the robot. Here's another one, which is Animal, which is a spin-off from ETH Zurich. All right. Okay, so let me start with my presentation. Okay, so today I'll be discussing Linorobot 2. So I'll be covering the short introduction, the supported hardware, and the robot architecture, and some tips and tricks on developing a micro ROS, and as well as how to go through the gazebo simulation of the project.
Hey, Juan,
Sure.
I'm back. I've got my phone back, so I think the audio should be clear now. When you want, I can do the Linorobot 2 demonstration.
Sure.
You want to do the talk first or do the demonstration now?
Maybe I do the talk first, and then you can do the demonstration.
Yes.
Okay. All right. So I started learning ROS using Turtlebot, but the project started with a question when I saw this competition in 2016. It's the Sample Return Robot Challenge. Well, the Turtlebot is a great platform for you to learn ROS, comes with a lot of off-the-shelf packages, and just runs right after the shelf, right? But then how a question comes about, and how do I go about building my own custom robot, right? Like I see here in the robots in the Sample Return Challenge, like you have 4-wheel drives, different types of kinematics, and different types and forms of robots, right? And so I built Linorobot, right? So it is a suite of open source ROS compatible robots to provide students and developers and researchers a low cost platform to create ROS compatible applications, right? Then the idea is to build the robot with easily accessible parts and hobbyist parts that makes it easy to build. So it started back in 2016. So now this is a version 2, which has support for ROS2, which was initiated back in 2018 and it failed, right? Because of some packages issues. So right now it supports 2-wheel drive and 4-wheel drive and mechanism drive, and to do will be an Ackerman steering. So it's fully autonomous, and it comes with simulation tools. And you can feel free to join our community. It's called it's in the Google groups called Linorobot. So these are some of the robot platforms that have been built using Linorobot 1. And as you can see here, this is based from the IKEA box for 4-wheel drive and some tin cans, and converted into a moving robot, right? Using Linorobot 1. And in Linorobot 2, this is the current robot that I'm using to support development. So this is the left side is I'm using for 4-wheel drive, and the right side for 2-wheel drive. So it comes with a manipulator and LD06 slider, a pretty good computing power to do some experiments. So it comes with a pretty decent lineup of DC to DC converters, 5 volts, 12 volts. So I can mount sensors on it. And here are some of the robots that have been built by the community, right? So the idea here was to, the user started building small robot as a prototype. And then once he's gained confidence, then he started to scale up the robot into a bigger one, which is the main application of that he's trying to build, right? So what he's built here is an assistive device for elderly, where it actually can navigate autonomously, and it has this Z mechanism to support the person who wants to stand up or to sit down. And here's another research project by one of the universities called Proto-Robot. It's a 2-wheel drive robot with some sensing capabilities. And here's another one from one of the universities in Singapore. So they use it as in the robotics club to spark students, and as well as a robotics project to learn ROS. Right. And here's one I used for my work back in 2017. So it's been used to convert an electric wheelchair into a self-driving one. Right. So, sure. Okay, so the project itself supports a Nav2 navigation software, and here's pretty much the list of sensors and hardware that you could use on project. So for the laser sensors, these are pretty common sensors that you can buy out there. You have RP LiDAR, LD LiDAR, YD LiDARs. And as well as for the depth sensors, you have Intel RealSense and Z cameras, which mostly work with NVIDIA development boards. And in terms of the IMUs, you have the MPU 6050s, 91 series. And for microcontrollers, it only supports Teensy microcontrollers at the moment, but RP 2040s will be supported in the future. Okay. How do I get rid of this thing? All right. So here's the architecture of the robot itself. So the project itself comes with libraries, low-level libraries that you can use to control the wheels and encoders as well to calculate the velocity of the robot, and as well as an IMU to get the orientation of the robot itself, right? And within the project itself, which runs on the microcontroller, has some kinematics library to make sense from the velocity to translate it into motor commands, and as well as the encoder driver to get the velocity of the robot, right? And it uses MicroROS as a client library to expose all this data to the ROS ecosystem itself. So what happens is that all this data that's available on the microcontroller gets available to the host machine itself. So why is this good is that previously most of these data are only available on the host machines, right? And you won't be able to do this on the microcontroller because of the low resource available on the microcontroller, right? And here's the old architecture, which is based on the Linorobot one. So it's pretty much similar. It's just that it uses a relay node here. So the idea here is that the messages that's used for the odometry, which is the velocity of the robot and the orientation of the robot, is pretty huge for the microcontroller to use. So on the microcontroller side, it runs very minimal or very small messages. And when it gets to the host machines, is that this software packages rewraps these messages and publish it into ROS as a full-fledged standardized messages. All right. Okay, so I'll now talk about the firmware. So the main difference of the project is that most of the MicroROS libraries being used now is based on the Arduino IDE. So the main difference is that it uses platform IO for this. So it allows over-the-air updates. So you don't really need a screen and your keyboard to upload your firmwares. And the users get to choose the kind of IDE that you use. So for example, you want to use Visual Studio Code or Sublime or whichever IDE that you want. So Platform IO is just a software stack on top that allows you to upload the firmware and convert it into a .hex file and burn it into your microcontroller. Right, and some of the tips and tricks that really got me some time developing the firmware versus porting the version 1 is, I think it's very important to have some synchronization of time between the host machine and the microcontroller, right? As some of the packages are very strict in terms of the timestamps, right, on the package itself, just to make sure that the sensors being received by all these raw software packages is up to date, right? So the idea here is that it uses the API for MicroROS to get the timestamp from the ROS ecosystem itself and the time from the microcontroller, and then from there you can get the time drift, right? And so with that, you could use the timestamp with the time difference on publishing the data. So if you're familiar with ROS, so use the timestamp to use this in messages and publish in the ROS ecosystem. So for any questions? Okay, cool. So some of the key takeaways, I believe, is that when you're developing your own firmware is make sure that you calculate the time offsets, right?
Juan,
sure.
How is the TC connected to the host computer?
All right, so it's just through a USB cable.
So it's connected with USB.
It's micro USB to USB-A.
Yeah, I got it. Thank you.
Right. All right. So some of the key takeaways is that when you're developing a firmware using micros is and you're publishing a data, you had to handle your time offsets as to know the difference between the host machine's timestamp, which is basically the epoch timestamps, and the time difference on the microcontroller, right? And the microROS library doesn't handle reconnection by default, so you would have to do that by yourself. So why you need to handle reconnection is when you need to rerun some of the software and you need to reconnect to the microROS, so you need to handle that by yourself. And next thing is that when you want to have your own custom messages within the ROS ecosystem itself, I recommend to check whether the application that you're trying to do with a custom message is supported with with the existing ones, right? So you don't really need to reinvent the wheel, because compiling these custom messages could be really could be a headache, right? And lastly is you can use Platform IO as an alternative for an IDE. So if you do guys have any non-ROS related projects as well, you can take a look at Platform IO as an alternative to the Arduino IDE if you really fancy some different IDEs on your projects. Yeah. Okay, so here's the simulation architecture. So within the ROS ecosystem itself, it runs in a very distributed manner, meaning the components, the hardware components is really abstracted into the software components, right? So what we have here, for example, is that if you're running a robot here, regardless of whether you want to change the type of robot that is running here, it doesn't really matter onto the higher level applications that's running on top of your robots, right? So for instance, in this case, is that we do have this data that's being exposed in the framework and some of the control mechanisms to control the robot. So for Linorobot it gives you an option to run the robot in virtual world or the physical robot, right? And the good thing here is that you don't need to do any changes when you switch in between, as so which allows you to write application that's almost close to the physical robot when you're doing your applications, right? So here's how a configuration of a robot when you're building your own robot in the gazebo simulation. So the good thing about Linorobot is it gives you a very intuitive way and very simple way of identifying or structuring your robot, right? So all you have to do is define how much your wheels weigh or how big is the wheels and the base are. Then the project auto-generates the virtual robot as what you see on the right side, right? So if you were to do this from scratch, it might take a while, especially from the beginner's standpoint. It can be really a lot of a steep learning curve to get this started, but this project somehow tries to simplify for the user.
Yeah, I might say it's very good at that.
All right, thanks, Cam. Yeah, so just an overview of the packages that's running on the project. So for the autonomy, it's using a navigation tool, which is led by Steve McKenzie, and as well as for the SLAM toolbox that's used for generating the map and for basically SLAM algorithms running on the robots using SLAM toolbox, which is also developed by Steve McKenzie. For localization, it uses AMCL as particle filters to get the robot localized. And using the RealSense or Z cameras, the robot allows the robot to navigate and avoid obstacles in 3D. And it has an extended Kalman filter to filter out noises and fuse different sensors on board, right? And if you're pretty familiar with the topics that's being used, in an autonomous robot in the ROS ecosystem, this is mostly the common topics that you will see, and these are the available topics when you build a Linorobot project, right? And here's a short demonstration of the robot generating a map. And here's the robot autonomously moving. Yeah. So you do
Is
have the
that
map
real
here.
time or speed it up?
Sorry? Oh, this is real time.
Whose wheels and gear motors are those?
It's a 90 RPM motor, 12 kilogram CM. Yep, so here's another video of the robot and navigating. All right, that's all for my slides.
So those were 5-inch wheels on there, were they?
Right, yep. Around 4 inches, I guess. Yep.
Okay. How wide was that robot?
It's around 25 cm, so around 10 inches by 10 inches.
Okay.
Yeah.
Linorobot specs.
Right. Yep.
Juan, that
Let me
was
get a
really
quick-
excellent. Will
Look-
you be making these slides available to the club as well?
Yeah. So I sent a copy to Camp already,
Yeah,
so I think he'll be uploading
I've
this.
got
to,
it and I'll forward it to Al and we'll put it in the archive. Let me just go ahead and give a quick demo, if I may, of the Linorobot.
Back to you, Camp.
Yep, yes. And here's the, oh, let me share the screen. And this is the gazebo world. This is the Linorobot here. Now the stock Linorobot wheels are 3 inches and the chassis is 10 inches. And the LiDAR is up high and the camera's down low. I've taken Juan's URDF and modified it. So I've made my base 20 inches and I've made my wheel radius 2.5, so there's 5-inch wheels. And it's relatively easy to set your robot, build the robot you want, okay? So it's scalable. And there's the gazebo world. Let me launch SLAM and the RViz here. Thanks Jeff Sampson, by the way, and the Tuesday Ross discussion group. I was having some issues with this and we trimmed some things out and it seems to work more better. So here we're launching SLAM and RViz, Ross Visualizer, SLAM Toolbox, that is. And now finally, we'll launch the nav stack. Oops. Careful, we'll learn something about environments here. So here comes the navigation stack. Now here's my Ross visualizer. And let me set the view for 3D, or I should say not top view anyways. I want orbit. Let's do that. So this is the Linorobot. We've got everything going on here. I should say I haven't got everything going on. It's got the depth camera and it's got the LiDAR going. And so here's the RViz, the Ross visualizer. And here, as far as the robot is concerned, is the world, okay? And so, let's see here, I'll flip this around. try to get the same look on it. Okay, so let's add. So, okay, good. I've got local mapping. I've got my global mapping. I've got my path stuff in there. Cool. We're all set to navigate. Actually, this is pretty cool because we'll be navigating into unknown space and mapping it as we go along, which is much cooler than saving your map and navigating within a known map. So let's do a 2D goal pose, point, press, drag, mouse up, and the robot should be navigating here now. Yes. And I want to thank Jeff Sampson. We've got wheels. When I last left off, I was running it a particular way, and the robot would work, but my wheels would go away. Something about the transform between left and right wheel and the map. But regardless, by leaving off the URDF and or taking the use sim time off of the nav seemed to have fixed it. Thanks, Jeff. You still out there?
Yes, I am.
Jeff from Minnesota, ladies and gentlemen. So here we're mapping this environment. Are you not entertained? Back out. Now I'll let's do another goal post and let's navigate out here. And this is pretty cool the way it works because you see the goal planning stay as much as possible on known space before it gets into unknown space. Here's the problem with live demos. I'm gonna give them a much easier goal. Point, press, drag, mouse up. All right. That one was too much to figure out. But you see what we're doing here is we're mapping this gazebo world. And this is not to keep you from building a physical robot. The Linorobot project also, is a physical robot, okay? And they've got all these great Linorobot standard hardware, like Juan was talking about. It's got the standardized motor driver, standardized IMU. They've got standardized LiDAR, 3D cameras. I think Ross in Canada is working on a Oak D light version of that. Ross, you still online?
Yeah, I am. And I've actually posted a little measure of success getting the blankety blank Oak D Ross to work.
Fingerty and Pokerty?
Yeah.
You're practicing some Fingerty and Pokerty or whatever you call it. I'm trying to get this robot to navigate. It doesn't want to go out into the unknown space. But anyways, this is the problem with navigating. It doesn't know what's there. Once it knows what's there, it's much more comfortable. But it goes on to talk about saving the map and then loading in SLAM with the map. Juan.
So Camp, if I understand correctly, you have downloaded some of the components of Linorobot and run a simulation. And I'm curious how many hours you have into doing this to get this far.
Almost 40 years.
More than 40, you're not fooling anybody, but yeah, okay, on this project, how many hours?
Seriously untold, but that having been said, with Gazebo and Ross itself, the learning curve is steep, and so this is the middle way, okay, to do the simulation stuff, which I'm not. Before this, I wasn't really a big fan of simulation because I feel like, at least me, I'm not smart enough for that. I'm a sales guy, all right. It is that you end up spending a lot of times on things that don't matter, okay? And so I'd rather cut to the chase and build the physical robot, find all, give me the worst news, give me all the problems right here, right now. And so the long story short is this is a nice combination of Gazebo and RViz. It's got a physical robot component to it. Moreover, it's a good tutorial for Ross. It's what we were after with the sample reference, something that's teaches Ross, that's scalable, modular, and uses standard off part. I've been working with Linorobot for a couple of months now. Is that your question?
Yeah, more or less, that's my question. How many hours? But yeah, a couple of months, that kind of tells me.
Yeah, I'm in for 100 hours at least.
Okay.
This is Ross here. I can also attest that you can load. I mean, I did this just last week. I created a new virtual machine on my Mac and loaded in 20.04 ROS 2. I had that simulation going within a couple of hours. Juan's code is pretty good. It works virtually out of the box.
Oh, that's great.
Yeah, that's the
great to
question.
hear.
Minimum
community-
time to sim.
Yeah, go ahead. The community's active too, the mailing list and so forth.
Yeah, that group's Google is like the HBRC one is outstanding. Lots of folks are contributing.
So this is the world. And this is the visualization. This is what the robot sees. And I've modified this from the standard 3-inch wheel, 10-inch platform, upper LiDAR, lower camera to be the, 5-inch wheels, 20-inch wide and length, and then flip-flop the camera and the LiDAR. But when it comes to, again, where I come from on this, when it comes to doing the virtual stuff, this is nice. And then they actually have a segue into building the physical robot. Thank you very much, Juan. We're fans.
Thanks. I mean, yeah. And I mean, it's really important as well for the community to get more users at the moment. The more people, then the more robust the software gets. So yeah, looking forward to more users and feedback.
Let's give Juan a big round of applause. Okay, any more questions?
Yeah, is there a brushless motor controller?
Yep. So this has been raised, actually just been raised yesterday in the issues. So the question was, will this work in ODrive? So there are a few people who started the conversation. I think the answer is yes. So they even managed to get it working. I think one of it was a VESC controller, and one is ODrive, which is controlled by using PWM.
Yeah, and how do you get the odometry off the brushless motor?
Right. So in my experience, so this has been tested on those hoverboards. So the hoverboards actually comes, those are brushless motors, and it comes with encoders as well. So that stack has been tested on that one. And what other users do is they also use external encoders. So if you take a look at this, I forgot the name, but it's actually on Omron. Okay. Can I share my screen again?
Yes, please.
Right. You guys seeing this?
Yes.
Right. So you can let's see. Yep. So it's this type of encoders. Yeah. So for brushless motors, you could probably do some pulleys on the wheels, and mount external encoder on those brushless motors as a start. What else? Let's see if I have.
Also, where is the teensy code on the GitHub?
Say again?
Where's the code for the teensies on the GitHub?
Oh, right. Let me see. It's called Linorobot 2 hardware. Yeah. So inside here, it actually will walk you through from the installation itself, all the software tools that you will need. And you will go through the calibration just to make sure that before you even go through the ROS ecosystem itself, that you have done a smoke test on your hardware, and your velocities and your odometries are in a sane state, right? Yeah. So you have all these connections and stuff. Yeah. So to answer your question earlier, Cam, so this is how it's connected as well. So you have the microcontroller, and then you have your host machine, right? It's just connected using USB. Yeah. So yeah, back to the brushless photo. Did I answer your question? I hope I did. Yeah.
Thank you.
Very good.
For the IMU, you just, I'm kind of not familiar with when you or how you tie in IMU into the nav2 or whatever, but does it feed the IMU data, get published and then consumed by nav, somewhere in nav2 or somewhere else?
Sure. So how it works is that it uses the robot localization package, which is mainly an extended Kalman filter. So how it works is that it uses the velocity that's calculated from the encoders and the angular velocity that's calculated from the IMU. Yeah, and you wrap this together, fuses together, and comes with the odometry as odometry data that's being used by the nav2. So nav2 doesn't have an idea of what sensors running in the background, as it only interacts into the odometry topic, right? So its concern is basically I only care about the high level velocity of the robot, and it's up to the user how to come out with that data. And that's being done by fusing the encoder, through the velocity and the IMU.
Yeah. And through, sorry, but which package does the fusion? Is that something you wrote?
Oh no, it's been a de facto common filter used by ROS1 as well. So I'm using a ROS2 port of that. It's called robot localization.
Oh, just robot localizations. So you, but that's, is that part of when like Camp was launching the SLAM toolkit? It's part of that.
Yeah. So from the user standpoint, all you have to do is basically build the hardware and go through the tutorial, and then launch all the software packages, and it automatically does for you.
Right, but then when there's problems, it's good to understand how it's all working.
Sure. If I may share again.
Yes.
Right. Okay. So here's the thing here. So Linorobot 2 kind of assumes that you've gone through ROS1 and you had some experience, and you're like a user from ROS1 to ROS2. So it kind of skips a lot of steps and assumes a lot of topics and concepts. But Linorobot 1 kind of builds on top of that and kind of handles all these topics together. So if you take a look at the wiki, it actually has all the details on what's inside the software. Like what is inside the controller and what is required, and how do you even test odometry. Like for example, base controller, it explains to you all the common filters and what you would need on a robot. So if that's what you're looking at, yeah, I recommend to start probably on ROS1, which is Linorobot 1, or you could just use it as a notes. If what's happening, it's pretty much similar to how it works. The main difference is just the software ports that being used on Linorobot 2. Yeah.
Great, thank you.
Super fine. Thank you very much.
One other question: how long did you take to port from ROS1 to ROS2 for your initial get it working port?
I think 2 months worth of weekends. Yeah, around there. Yeah.
Okay, good. Yeah, because I have a small port of a third party tool that they didn't port to ROS2, and it has a LiDAR and it's got a CPU in there delivering a bunch of ODOM and map, and it's a mapping system and all that. And
right,
it seems like, yeah, it takes a little time you have to understand a lot of pieces to move that over, I think, and then get it working in RViz as well, which is, but anyway, yeah.
I think the most challenging part is looking for the equivalent APIs and the kind of behavior that I had in ROS1. As the thing is, I'm not just porting it as well, but I also want to consider from the beginner standpoint. So there's some behaviors that I try to achieve, like to accomplish a task that's more transparent and easy to use for the users as well.
You had to abstract, you had to change the abstractions then, essentially.
Exactly. Yep.
Yeah. And then what about with, how ROS2 has components and ROS1 had what was it called? Applets or nodelets?
Nodelets, yep.
And so did you have to map any nodelets to components at all in your system, or is that not an issue?
Not exactly. As one of the use case that I have is, someone might probably need to cross the network, and especially when when you're offloading some of probably of the vision parts, or just by controlling the robots. Although some of the sensors, but not written by me, the drivers, it comes with ROS components. I think the Z camera, since it's pretty heavy, it has some options to run the driver using ROS components, just due to the network traffic issues, and yeah. But for this part, it doesn't have to include any ROS Node 2 components. Yeah.
Skimming over your code, if I read it right, it looks like there's no custom ROS2 source code that you had to write. All the hardware stuff was done on the Arduino side. And
yep.
Okay, excellent.
You mean the teensy side, right?
Yep. And most of the libraries were actually just reused from the old one.
Right, I was trying to see if you're using robot hardware abstraction, which.
Oh, no.
Okay. I have to say, I'm very impressed with this. I really appreciate the effort you put into this. It's going to help me a lot.
Thank you.
Definitely.
Very good. Big round of applause. All right, Juan, thank you very much. Thus concludes our meeting and presentation this evening. Let's see. I motion this meeting be adjourned. Do I have a second?
Second.
For $1, I will.
All those agree,